So today we are going to be comparing linear functions. So when we compare, we're going to look at their similarities or differences. And we want to, our goal is to be able to make two statements, okay? So let's just take a look. What were we looking for the other day when we were doing the tables, or even like in our exit ticket? The differences, right? So this one was an increase by 2, increase by 2, increase by 2. This was an increase by 4, increase by 4, increase by 4.
So is that 4, 2 then, right? That's 4.
4 over 2 would be the slope. Yep. And then you want to reduce that. So what does 4 over 2 actually equal?
2.
2. Yep. Okay. So then on the next one, it was an increase by 1, increase by 1, increase by 1, and also an increase by 1, increase by 1, increase by 1. Okay. So we were brought up to just a perfect example here. The slope of the first graph has a slope of what? You guys just did it.
4 over 2.
4 over 2, which is 2. And the slope of the second table is 1 over 1, which equals 1. Okay.
So if we have a number like that, do we have to put, so if we put 1 over 1, do we have to put it into like?
No, that's fine. Okay. So now let's make two statements about this. So if we were observing these two situations, what could you tell me, like graph this first table to this table? You guys have any ideas? What would,
both linear functions
they're both linear functions. How do we know that they're both linear functions?
because they both are constant.
Yeah, they both have a constant change. So both are linear functions because they both have a constant change. So from the table, we were able to find the slope. So how could you tell us, what could you say that would be different? You know, like if we were finding their contrast. Go ahead.
Would the one that 4 over 2 would that slope be bigger?
What was that again?
Would the slope be bigger?
Yes, that's exactly what I wanted to get at. The slope for the first table is greater, okay? So that would be like how they're different. So they're the same, they're both lines, but they're different because the first table, so the table on the left has a steeper slope. So we were able to get that information from the table. Okay. So now we're going to look at these two graphs and we're going to make comparisons. We can find at least two things. What do you guys think? Yeah, they're both positive. They both increase from left to right. They're both positive. Yep, sorry.
I keep forgetting how you can spell that for left.
It just is going up from left to right like you're reading.
So the line starts at the bottom, like along that bottom left, it's positive.
Now, if you guys were going to just examine these a little bit closer, we could find the slope, right?
Yeah.
I don't know if that's perfect. I don't think this one's perfect, sorry. I'm gonna boot that one out of there. Up.
The one on the right.
Up 3 over 5. What was that? You had a good comment there. The one on the right is, are you doubting yourself? Okay, so this one has a slope of 3/5. And this one has a slope of up 1 over 1, up 1 over 1.
That, so the one right.
Yeah, this one is steeper. The graph on the right is steeper. And you technically wouldn't even really need to find that slope to answer that question, but it is helpful. Kind of confirm it. The bigger the number, the steeper the graph. Okay. The next page, it says since tables lead to graphs and points from graphs can be recorded in a table, it's easy to compare a linear relationship written in a table with one graph. So we're going to compare. Now we've got two different things. So a couple things you can look for is the first is the direction. Does it positive or negative? And then the second thing you can look for in both of these now that you know how is the slope. So if we practice with the first table there, it was going from 1 to 2, which is a positive 1, 2 to 3, which is a positive 1, 3 to 4, positive 1. 1 to 2, positive 1, 2 to 3, positive 1, 3 to 4, positive 1. Our slope is 1. Now we can go to our graph. And I'm gonna try to find some nice points here. It's hard on this little graph. Like, I don't know.
And -6, -4.
Yeah, that's a good one. Yeah, I'm okay. So then we would go up 1, 2, 3, right? And we would go over 1, 2, 3, 4, 5. So -3 or positive, sorry, 3/5. So who's bigger, 1 or 3/5? 1 is bigger. Okay. So the table is more steep, we could say. What statement could we make about the direction? Even though we don't have a graph of this, what do we know about it?
More than likely positive.
It is positive, yep. Okay, so both are positive. So yes, one is more, the table is steeper, but they are both positive. Okay. The last little part, it says circle the function with the greatest rate of change. So what's another word for a rate of change? Slope. Draw a box around the function with the smallest rate of change, or as we know it, slope. So we have 4 different slopes here. Let's just work from left to right and figure what they are. So the first one, look for some nice intersections here. Maybe like -4, -1. Maybe right here.
3, 8.
Oh yeah, that's a good, I don't know if it's 3, 8. It's hard to tell if it's like which one of these it is. It's kind of a tough, okay, let's count. 1, 2, 3, 4 over 3. 1, 2, 3. Okay, then 1, 2, 3, 4 over 3. Yeah, I would say that. They look pretty good. Okay, then the next one, I'm going up by ones, right? What about on this side? Am I going up or down?
Minus.
Minus, yep. So down by ones. So my slope is
Negative.
-1 over 1, which is just a -1. And then on this next one, I would say this one looks like a good candidate. And this one. See, I kind of try to map it over, like up 3 over 1, up 3 over 1 doesn't look very good. So let's go to this one here. So 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3. Okay. And then our last one, 1 to 6 is 5, 6 to 11, 5, 1 to 2, 2 to 3, 1. So this is 1/5. Okay, so now we talk about with slope, not to write them as a mixed number, but this is going to be more helpful. Okay. So as a mixed number, this is going to be 1 and 1/3, right? And this is going to be 2 and 2/3. So if you like, that's just a good reference point. Who is the biggest one?
The 2 and 2.
2 and 2/3. So this guy, it says circle the steepest. Okay, and then we're gonna put a square around the smallest. So who's smaller? -1. Yep. Now, this is going to, I'm gonna pause you for a second. So is it smaller to go down by -1 or down by 1/5? 1/5. So even though this is negative, the change is still faster. Okay, so this one is actually the smallest rate of change, even though this is positive versus negative.
What?
Okay, yep.
Are you gonna put this on the test?
Nope, I just want you guys to think about like which one's steeper. It doesn't matter if it's going up or down, okay, necessarily. So the question would be more clear. I'll tell you that much. Okay. So I don't know, maybe I should back that up. Just draw a box for the function with the smallest rate of change. If this said smallest slope, it would be a -1. Okay, because technically smaller, I just want to be clear, like going forward on how we should talk about it. So it is a smaller number, but it's not less steep, I guess. Mason.
What isn't rate of change the same slope?
I just was trying to read it with the word slope in there to see how it was perceived. For example, like if someone asked me, well, which one has the greater rate of change? I would say that -1 is a greater rate of change because it's decreasing faster. Okay. And then this one is going up faster. But if you ask me like which one is the greater slope, 1/5 is greater than -1. So I think it just depends on how it's perceived. Okay. And the reason why I kind of wanted to talk about that was because when we compare these, okay, like I just glanced at number 4. When I glanced at number 4, I knew that it was going to be negative, and this is positive. So when you talk about rate of change, I would like you to compare the actual fraction, let's say. Okay, don't worry about if it's positive or negative.